Hello everyone, hope you all are able to hear me, and yes, I can see you can hear me, and welcome to the discussion today. As you have already seen, today's topic of discussion is acids, bases and salts. This is grade 10 topic for all syllabus. Okay, so now let us begin with the general discussion. First of all, what acids are. Okay, what do acids actually contain? Okay, like what are the classifications? Now there is something which is not explained in all the topics, which I'm going to tell you now. See, acids are those substances, like the name acid came from the word acidus, which means it is a sour to taste. Okay, if it is a sour to taste, then we say it is acidus. Okay, now all these acids will be having that sour taste in them. They are sour to taste. So if you take lemon juice or tamarind, these all will be having that sour taste in them. So we call them as acids. Okay. Now coming to understanding the chemical properties of these acids. Okay, we'll be discussing first with what actually these acids have. What, like in this today's class we'll be discussing about properties of acids, both physical and the chemical, in terms of their reaction, and we will know what all acids will have in common. Then we will know a bit about bases. We will know about the strength of the acid and strength of the base by means of this pH. Okay, and we will also discuss about few salts. Okay, classification of salts also we will discuss. Now coming to the chemical properties of acids, starting with the first one, acid. See, we define acid as any substance which is having H plus ions in them and gives off their hydronium ion upon ionizing. See, this Arrhenius was the scientist who first came up with this definition of an acid. He stated that every compound, any compound which is having H plus ions and gives off that H plus ions. Remember the word H plus ions. Upon ionizing, he termed it as an acid. For example, if you take HCl, upon ionizing, it gives us HCl. Upon ionizing, it gives us H plus and Cl minus. H2SO4, H2SO4. Upon ionizing, it gives us H plus and HSO4 minus. So like that, it is giving us H plus ions upon ionizing. That is what he stated. Now, there is a contradiction to his statement that some compounds, they don't actually possess these H plus ions, but when they are dissolved in water, they are able to produce hydronium ions. They are behaving like acids. For example, you can take carbon dioxide. Carbon dioxide is a gas which does not have any hydrogen in it, evidently, because the symbol for carbon dioxide is CO2. Now, this carbon dioxide, when it is dissolved in water, we are getting an acid, carbonic acid. Okay, now how is this happening? How is a compound which is not having hydrogen, when dissolved in water, is actually changing into an acid, is something which Arrhenius could not explain. Okay, now what is the actual definition of acid? We'll be learning in the subsequent part of this video. First, let us see properties of acids. Okay, acids are sour to taste. They are corrosive in nature. What is the meaning of this being corrosive? Okay, corrosive means it is like having the ability to eat away the top layer of any substance. Okay, so when the top layer of any material is being eaten away, it being damaged or oxidized, whatever it is. So what happens? You are losing the strength of the top layer. That is called corrosion. So all acids are corrosive in nature. They are highly corrosive in nature. Okay. Now coming to chemical properties in simple. Okay. First we will know about please, no personal discussions. Everyone who are watching this video are personally known to me. Okay, so no personal discussions, anyone. So coming to identification of an acid. Okay, We can actually identify any acid by using some indicators. Okay, as the name suggests, indicator, it is giving us an indication. Okay, so what is it indicating? It is giving us a way to identify whether the given substance is acid or not. Okay, so see, for example, if we consider, uh, for example, I can take turmeric. Okay, see, this is something which I should have said later, but let me tell you in forehand so that you get an idea about what indicator is. As you have already learned in your 7th standard and 8th standard, okay, if I take turmeric and add little bit of lime to it, okay, or little bit of soap to it or shampoo to it, whatever, you see there will be a change in the color. Okay, that change in the color is actually indicating something about one of the constituent, that is the lime. Okay, the lime what you have added, don't get confused between lemon and lime. Okay, lemon is a citrus fruit which is acidic in nature. Lime is calcium oxide which is basic in nature. Okay, now this turmeric is the substance which is behaving like an indicator. It is an indicator which is explaining about the basic nature of the lime. Okay, so we have aromatic indicators and allopathic indicators. If we are able to identify depending on the smell, that is aroma, then we call them as aromatic indicators. Allopathic indicators are those which show difference in the color. Okay, so when it comes to the matter of identifying the difference in colors, we generally use four different indicators. First one is litmus, something which you already know, you must have seen in your lower classes. We have red litmus and blue litmus. Okay, now any acid will be changing the blue color litmus paper into red color, so that is one way of identifying an acid. Second one is methyl orange. Okay, methyl orange, as the name suggests, it is dark yellowish in color, and when that is added to an acid, it will show a change in color by which we see the changing into yellow color. Okay, now when third one is phenophthalene. Okay, phenophthalene is a colorless liquid, and this colorless liquid, when it is brought in contact with any acid, okay, we see that it remains colorless. There will be no change in the color whatsoever. Okay, from this we can say that litmus and methyl orange are better indicators of an acid, because phenolphthalein does not show any change in the color. We don't use this to test for an acid. Okay, if it is test for a base, yes, it changes its color into yellow color, so we can identify that. Okay, now coming to pH, the term pH actually refers to percentage of hydrogen ion concentration. Okay, so depending on how strong it is, first of all, we can identify whether it is acidic or basic. At the same time, we can also know how strong an acid or a base it is. Okay, now coming to the next part, reactions. First of all, reaction with acid. Okay, so sorry, acid reaction with metal. See, we already have learned in metals and non-metals chapter about the reactivity series, and we already know that all metals will be having hydrogen in them. It's a common element. Okay, any acid you take, from the strongest acid, HCl, H2SO4, HNO3, so on up to the weakest of all acid, acetic acid, CH3COOH, till the weakest of all acids. You see, everything has a hydrogen ion, which can be which will come out upon ionizing. Okay, So all hydrogens or all acids are having hydrogen as a common element in them. Point number one. Now coming to the reactivity series, all metals which are above hydrogen can displace hydrogen from its compound. So what is happening if we are adding any metal which is above hydrogen, or this acid is reacting with any metal which is above hydrogen in the reactivity series, hydrogen gas is given out. For example, Cl, hydrogen chloride, hydrochloric acid. Yes, here I want to specifically bring it to your notice the difference between hydrogen chloride and hydrochloric acid. Hydrogen chloride is that compound which is not acidic in nature. Please try to understand the difference. Hydrogen chloride is not acidic in nature. Okay, it is a compound which is having hydrogen and chlorine. It is a polar coordinate compound. Now, this hydrogen chloride, when dissolved in water, that is when this will form, it will be having free H plus ions, movable H plus ions, and that is when it will be behaving like a acid. Okay, so when it is in its gaseous, colorless gaseous state, it is hydrogen chloride. When that is dissolved in water, then it is hydrochloric acid. So now I am taking hydrochloric acid. This hydrochloric acid, when it is reacting with any metal which is above hydrogen in the reactivity series, usually we use zinc. Okay, it gives us zinc chloride and it gives off hydrogen gas. Okay, let us try to balance this. I have two hydrogens and two chlorines, so I think this should be doing the trick. So we have 2 HCl plus Zn gives rise to ZnCl2 plus H2. So hydrogen gas is liberated. You can try the same with any metal. Okay, if I take uh, iron, H2SO4, combining with iron, it gives me Fe2SO4, K plus H2, ferrous sulfate, and hydrogen gas is liberated, balancing to Fe. So what do we notice? Whenever there is an acid that is reacting with metal, we will be having this hydrogen gas liberated out, provided that metal is more reactive and compared to hydrogen. There is one more important thing here. Nitric acid is one substance in which when it is reacting with metal, it does not give off hydrogen. Okay, it does not produce hydrogen. Reason being, this nitric oxide which is formed, HNO3, upon ionizing it gives H plus and NO3 minus. This being a very strong oxidizing agent, it will immediately oxidize the other hydrogen to form water. Okay, so you will not see the evolution of hydrogen gas when it is the reaction between a metal and a nitric acid. So now let me tell you one trick. It will be difficult. One of my students was actually asking this. Okay, it is difficult to remember each and every reaction like this. So we have a generalized form. Okay, acids react with metal, they give hydrogen gas. We remember only this, provided we are aware of all the conditions that this metal should be more reactive than hydrogen. That's it. Okay, so this is how metals react with hydrogen. Okay, now the same thing is explained with the help of an activity in the textbook. Now coming to the next part, reaction of acids with carbonates and bicarbonates. Acid plus carbonate, CO3, or bicarbonate, HCO3. Okay. Now, what happens when metal acids are reacting with carbonates or bicarbonates? Remember, one thing is for sure, something should be eliminated. Okay, what will be eliminated in this case? It is the carbon dioxide. carbon and oxygen. So whenever acids react with carbonates or bicarbonates, we get carbon dioxide. Okay, for example, if I have taken HCl, why am I always taking HCl as an example? Because it is easy to understand. Okay, acid, when it is treated with say sodium carbonate, Na2CO3. Okay, now what? Oh, CO3. Let me write it neatly. Na2CO3. Now, in this reaction, what happens? NaCl, sodium chloride is formed, so chlorine and sodium are done. Okay, I already said carbon dioxide is formed, so CO2 gas is formed. What else is left out? Oxygen and hydrogen, so H2O. So whenever any acid is reacting with carbonate, carbon dioxide is evolved. The remaining compound we can easily identify by knowing the anions and cations of the reactants. Okay, so similarly bicarbonates also. So whenever acids are reacting with carbonate or bicarbonate, they give us carbon dioxide gas. Again, remember the same thing. This is the root equation. Okay, we don't have to memorize each and every equation. Suppose I have sodium carbonate. Instead of sodium carbonate, if I have HCl reacting with the calcium carbonate, then what do I get? Carbon dioxide is common. Instead of sodium chloride, I'll be getting calcium chloride, water. If it is sodium bicarbonate, NaHCO3, then I'll be getting NaCl, water, and carbon dioxide. Same. Okay, it is the same compound that will be formed. Only difference will be with the balancing of the equation. Okay, so this is about reaction with carbonates and bicarbonates. Now what happens if it is reacting with sulfates and bisulfate? This is not mentioned in NCRT textbooks, but let us discuss. It makes no very big difference. Okay, it's almost the same. So acid, when it is treated with, okay, sulfates or bisulfate, sulfate is SO4 2 minus. Okay, this CO3 HCO3, this CO3 2 minus and H2O3 minus. Okay, sulfates and bisulfates or bisulfate, HSO4 minus. Okay, in this case, it is very easy to guess. If acid is reacting with carbonate or bicarbonate, you are getting carbon dioxide. In the same way, if acid is reacting with sulfate or bisulfate, you should be getting sulfur dioxide. As simple as that. Okay, so this is the root equation. In your textbook, this same point would be very clearly mentioned only if we have the habit of reading each and every line of the textbook, and reading between lines is very important. Remember, textbook is always framed by a group of people who have their expertise at the subject for very like many years, not one or two. Okay, keeping the entire information compact in a very small place. So in that case, it is very important for us to learn not only each and every line, but also between the lines. So make sure you read the textbook thoroughly. Then you will be able to identify the beauty of science and also the methods of learning it very easily. So now see, almost 3 pages of a textbook are made very simple with 3 lines. Okay. Now coming to reaction with acids and bases with each other. So acid and a base. So acid plus base. Okay, now this reaction between acid and a base is called a neutralization reaction. Neutral, we call neutral substances which are neither acidic nor basic. It is very simple logic to understand. When acid react with a base, the acidic property is nullified by the base and basic property is nullified by the acid, and finally we are getting a compound which is neither of those. Okay, so this reaction is called neutralization reaction. Now what are the neutral substances that can be formed? So acid react with a base to give us a one neutral compound, which is neither acidic nor basic, is water. And the other thing, which is neither acidic nor basic, will be a salt. So this process of neutralization gives us only two products. Gives us only two products, salt and water. So you can define neutralization reaction as the reaction in which an acid react with a base to give salt and water. Okay. Now, during this process, during this neutralization reaction, heat energy is given out. So that amount of heat energy given out during neutralization reaction is called heat of neutralization. Okay, 13.6 joules energy per mole. 13.6 joules of heat energy will be given when 1 mole of a strong acid react with 1 mole of strong base. Okay, now after this, let us see the reaction between metallic oxides and acids. Now, before discussing about the reaction between metallic oxides and acids, I would like to give you the definition of a base. Any metallic oxide, metallic hydroxide, or hydroxide of ammonium ion, any metallic oxide, metallic hydroxide, or hydroxide of ammonium ion. These three can be, any of these can be termed as a base. So base is metallic, like a component which is having metal in it. As I was saying, metallic oxide, metallic hydroxide, and hydroxide of ammonium ion. Now, uh, clearing. So now, coming to bases. See, in bases, as I said, metallic oxides, metallic hydroxide, hydroxide of ammonium ion. We have, yeah, we have, say, calcium oxide. So this is a base. Okay. Now, our idea is to learn what will happen when this metallic oxide is treated with an acid. So this metallic oxide is treated with an acid, say HCl. Okay. Now, during this reaction, what we notice, there will be an exchange of radicals. So this will break. Let me explain one equation in detail. So this calcium oxide is formed of two ions, that is Ca2 plus ion and O2 minus ion. Now this HCl is formed of two ions, H plus ion and Cl minus ion. We have learned about double displacement reaction in the first chapter of NCERT, that is chemical equations and reactions, steps of chemical changes. So there will be an exchange of radicals. This calcium will combine with chlorine and this hydrogen will combine with oxygen. So we get CaCl2, calcium chloride, and water. Now you see we are having a salt and water form. So when acid is reacting with metallic oxide, we are getting salt and water formed. From this, we can actually prove that this calcium oxide is basic in nature. Okay. So whenever metallic oxides react with acid, we are having salt and water form, which proves that metallic oxides are basic in nature. Now, what will be the color of this basic solutions in litmus? What color change do they show? A base actually changes red litmus to blue color. Now coming to the next part of the chapter, as I already mentioned it, what is common in all acids? All acids will be having hydrogen in them. Now, that while explaining that, I spoke about Arrhenius theory of acids, wherein I mentioned that all acids will be having H plus ions and gives their H plus ions upon ionizing. That is excuse me, that is when there was a contradiction that carbon is not having hydrogen in it at all, but it is behaving like an acid when dissolved in water. Okay, now after that there was a small change. They brought a small change in the definition, and they said that any compound which is having hydrogen in it and gives H3O plus ion, hydronium ion, is called an acid. A compound which is having hydrogen in it and gives H3O plus ions, hydronium ions, when dissolved in water, are called acids. Okay. Now, these acids are again classified into organic acids, inorganic or inorganic acids. All acids which we are getting from natural sources, like as I already mentioned, all citrus fruits will be having citric acid in them. Lemon juice has citric acid in them. Okay, and then sting of ant will be having stearic acid in that. So these kind of acids which are coming from living organisms, we call them as organic acids. On the other hand, we have mineral acids which are prepared, manufactured industrially, like HCl, HNO3, HTSO4. These all come under mineral acids. Now acids are classified into strong acids and weak acids also. We say an acid is a strong acid if it is completely ionizing. Okay, an acid which is completely ionizing in a single stage, we say it is a strong acid. Okay, and those acids which cannot be ionized completely in a single stage immediately, we call them as weak acids. So that is how we have classified strong acids and weak acids. Okay, now these are again classified depending on their basicity. Okay, if that acid is having only one hydrogen, we say it is a monobasic acid. If that is having two hydrogens, we say dibasic acid. If it is having three hydrogens, it is tribasic acid. Now let me be more clear. Okay, if that acid is having only one ionizable hydrogen, then we say it is monobasic acid, ionizable, okay, which can be separated. Similarly, an acid which is having two ionizable hydrogens, we say it is a dibasic acid. If an acid is having three ionizable hydrogens, we say it is tribasic acid. H3PO4, phosphoric acid, is an example for that. Okay. Now, coming to the next part, that is the strength of an acid. Okay. We know that an acid which is immediately ionizing, we say it is strong acid. But how do we measure the strength of the acid? For that, there is a scale which is giving us a proper measure called pH scale. Okay. pH, small p, capital H. Okay, this pH actually refers to percentage of hydrogen ion concentration. Okay, small p, this p refers to percentage and capital H is the symbol of hydrogen. So percentage of hydrogen ion concentration, and it is given by the formula negative logarithm of H plus ion concentration. See, whenever we are writing the ion in square brackets, it means it is the concentration of that ion. So negative logarithm of hydrogen ion concentration will give us the pH. Okay, however, this formula is not required for CBSE students, but for state syllabus of Andhra Pradesh, this is important, and based on this, numerical questions also can be expected. Okay, now how do we use this pH? Okay, pH is actually a solution, okay, which shows different colors depending on the percentage of hydrogen ion concentration of any liquid. If I have to draw the pH scale, it has readings starting from 0, 1, 2, 3, 4, 5, 6, 7 till 14. Okay. Okay, please excuse my excellent drawing skills because these are supposed to be equal, making this as the center. Okay, yeah. Now we see that in this case, at this point, see the value from 0 to 7, from the value, if the value of pH is from 0 to 7, anywhere between 0 and 7, it is acidic in nature. Okay, now if the value is from 7 to 14, anywhere from 7 to 14, it is basic in nature. Okay, now I would write like this: H plus OH minus. Now what we are understanding, if the value is increasing from 0 to 7, H plus ion concentration is decreasing. Okay, it is decreasing. H plus ion concentration is decreasing. That means the acidic property or the strength of that acid is also decreasing. So at this point 7, you see this distance and this distance are equal, which means that it is having equal concentration of H plus and OH minus ions. If it is having equal concentration of H plus and OH minus ions, it means it is water. So pH of water is 7. Now, uh, if the value pH value is less, say it is 0.5 or 1, that means it is a very strong acid. And as the value is increasing till 7, its acidic property is decreasing. Okay, and it has become a neutral solution by the time it reaches 7, and it's furthermore decreasing till 14. Whereas basic property, when you are moving from, if the pH value is from 7 to 14, anywhere from 7 to 14, the basic property is going on increasing. Okay, so if like if the acidic property decreases, the basic property increases, and at one point, that is 7, it is totally neutral. Okay, now excuse me, how is this pH actually helping us? Do we need this? Yes, we actually need to know the pH value of many things around us. If you speak about, like, if, because we are living in a country for which agriculture is the backbone, knowing the pH value of the soil is very, 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 very important. Okay, if we know the pH value of the soil, then we can actually grow the plant which can withstand that particular given pH, or we can actually give a kind of nutrient that will neutralize the high acidity or high basicity. If at all we come across the news for farmers, given separately and specifically for farmers in Doordarshan or Akashvani or any of the radios and television channels, we will come across terms like using ammonia as a fertilizer. When you are sprinkling ammonia, remember ammonia is actually, it does not come as a simple compound, it comes as a composition of something. So what is it doing? That being, suppose ammonium phosphate, they say, okay, that being non-metallic in nature, it could be slightly acidic. Okay, phosphate and ammonia, it could be changing the composition, changing the pH. Okay, sometimes we sprinkle nitrogen. Okay, so like that, what is happening, depending, if it is more acidic in nature, they will prescribe as some basic salt, which actually brings down the pH to normal. If it is more basic in nature, they will prescribe us with an acidic salt, which will bring down the pH to normal. Sometimes potassium bicarbonate is, they say, or phosphate, biphosphate. So like that, depending on the pH of the soil, we actually change the salt that we are sprinkling. Okay, so knowing that pH is important for agriculture. Now coming to uh, what we say, that animal sting. Okay, ants, when ants sting, they actually secrete, they inject that acid, stearic acid, into our skin, which actually causes rashes, pain. Okay, now how do we come across, how do we overcome that? Okay, for that, what we can do is take some paste, toothpaste, which is basic in nature, apply on that. So that acidity is neutralized by the toothpaste. Saying that toothpaste is basic in nature, yes, our mouth we choose a lot of food, different types of food, and thereby what happens, it becomes more acidic. To neutralize that also, actually we use this toothpaste which is basic in nature. If the pH value is not maintained, then it may lead to tooth decay. Okay, now our body actually has HCl produced in it. So that HCl which is produced is helping in breaking a complex compound into simple compound. Does acid really break a complex compound into simple compound? It surely does. Uh, I'm sure almost everyone had the experience of eating a pizza. Okay, now what is the perfect combination for pizza? Coke. Have you ever noticed that even if you keep a huge piece of pizza to your full, like in your mouth completely, leaving no gap, and then somehow you like make some space to take one gulp of Coke, you will notice that the entire pizza would be crumbling into a very small gulp, like something which you can swallow easily. Now, what happened here? In this case, this carbonic acid, that is the soda what you have taken in form of Coke or Pepsi or whatever. I am not canvassing for any of these organizations, any of these companies. Okay, so anything. What is it doing? It is being in nature is actually breaking a complex compound of this uh, pizza, which is made up of carbohydrate. Okay, into simpler substances. That's the reason why you are able to swallow it very easily. Okay, so the acids can break a complex compound into simpler substances, and that is how your digestion is actually going on. Okay, in your body. So HCl, which is produced in the stomach, will break a huge complex compound into a simpler compound so that it can be easily absorbed. Excuse me. Now, coming to the next part, salts. Okay, one must be wondering, like we discussed only about acids, we did not discuss about base. Okay, when we were discussing about acids, simultaneously we have discussed about bases because we have learned what bases, like what is the definition of base, and we have learned how bases react. When we are discussing about reaction between acid and base, we ultimately learned about the reaction between base and acid also. It is the same thing, the other way around. Now, coming to salts. See, we know that these salts are formed because of a chemical reaction, that is the reaction between acid and a base, that is neutralization reaction. So salts are neutral. That is what we jump to the conclusion. But remember, if the reaction is between a strong acid and a strong base, yes, we are getting a salt which is neutral. But if the acid is strong and base is not strong, then what will happen? That is when the acidic property will still remain in the salt and we will be getting an acidic salt. Similarly, if the reaction is between a very strong base and slightly weaker acid, then the salt formed will be a basic salt. So we are having acidic salt and basic salt also. We have mixed salt, complex salt, which we'll be learning in the higher classes eventually. Now, excuse me. Coming to these salts, the most significant of all salts is sodium chloride. Okay, NaCl is a very important compound because that is the starting product for many other salts. Okay, see this sodium chloride when dissolved in water, it gives us salt water. That salt water or salt solution, we call it as a brine solution. That brine solution, NaCl, when it is subjected to electrolysis, okay, NaCl plus H2, excuse me, plus H2O, okay, when it is subjected to electrolysis, it gives us NaOH, sodium hydroxide, which is a very strong base, plus H plus and Cl minus. So what is happening? We are already getting a base. Okay, or rather, let me simplify this, not making it complex. It gives us hydrogen gas and chlorine gas. Okay, now this chlorine gas which is evolved, this chlorine gas, when it is treated with calcium hydroxide, CaOH twice, it gives us a very useful compound called bleaching powder, and its molecular formula is CaOCl2. Okay, so the molecular formula of bleaching powder is bleaching powder. Okay, so this bleaching powder is normally commonly used, okay, in our household for cleaning and also for other domestic purposes like yeah, cleaning is one important thing, and the other purposes are like bleaching, like tanning, removing the color pigment from any compound or any substance or a fabric. Okay, so that is the use of bleaching powder. Now coming to the next part, this sodium chloride, as I already said, sodium chloride is very important compound. This sodium chloride, when it is treated with ammonia NH3 in the presence of water and carbon dioxide, H2O and CO2, it gives us two important compounds. One is ammonium chloride, NH4Cl. This ammonium chloride is a very important laboratory reagent. We have seen this, and it is also used in fertilizers. And the other important compound is NaHCO3. Okay, sodium bicarbonate. Now, what is the importance of the sodium bicarbonate? This sodium bicarbonate is called baking soda. Okay. Now, what is the use of baking soda? Okay. To know the use of baking soda, let us see what happens if baking soda is heated. This NaHCO3, upon heating, it gives us Na2CO2 plus H2O plus Na2CO3. Okay, Na2CO3, sodium carbonate plus H2O, water plus carbon dioxide. Now, this is playing a key role. This carbon dioxide is actually playing a key role. What is the role played by carbon dioxide here? See, carbon dioxide is a gas which is heavier. Okay, now suppose this sodium bicarbonate, NaHCO3, otherwise baking soda, when I dissolve this, when I mix this in any batter, or say like the mix, cake mix, for example. Okay, now in the dough, rather, when I mix it thoroughly, okay, what happens? It is totally dissolved, distributed equally all over the dough. Okay, now when I put it in the oven, this is happening. Sodium carbonate is formed, water vapor is formed, carbon dioxide is produced. This carbon dioxide, being gas, it expands, and this being heavier, it will not be able to escape out of the dough. So what happens? It produces a bubble, it produces an empty space around itself. Now that is what is actually making your cakes or bread fluffy. Okay, so so now we understood that this baking powder is like preparation of a cake is also having some chemistry involved in it. See, science is everywhere around us. Now, this baking soda, when it is heated, okay, we are getting this compound, right? This compound is nothing but washing soda. So, again, you see, where did we get all this from? We got everything from sodium chloride, and that is the reason why sodium chloride is actually a very important compound. So, let us see from the beginning. Sodium chloride, when dissolved in water, we call it as a brine solution. That brine solution, when we are doing electrolysis, it is giving us sodium hydroxide, hydrogen gas, and chlorine gas. Now, this chlorine gas which is evolved, when we are treating with calcium hydroxide, we are getting COOCl2, which is bleaching powder. The sodium chloride, which is uh, reacting, or brine solution, we can say NaCl plus H2O brine solution, when it is treated with ammonia in the presence of carbon dioxide, it is giving us ammonium chloride and baking soda. Ammonium chloride is a laboratory reagent, and we are getting baking soda, which is used for cooking purposes. Now, that baking soda, when we heat, we are getting washing soda. Okay. Now, coming to the next part, which is interesting. Okay. See, we have a saying that all that glitters is not gold. Okay. As far as salts are concerned, we classify them into two types. One is crystalline, the other one is amorphous. Okay. One is a crystalline salt, the other one is an amorphous salt. Now, what is a crystalline salt? Very simple. Which shines is crystalline. Okay. Now, why is that shine coming? This you'll be learning in your plus one. Okay. But let me just give you a heads up. We have sodium like this. This sodium we write, like if I have to draw the molecular structure, this is the molecular structure. See, we have every sodium like it is having a bond with chlorines all around it. Okay. And every chlorine is associated with a sodium each. So like that we are having this. This I have shown only in two dimensions. Imagine the same kind of layer in front of this and back also. Okay. So like that, actually one sodium is not combining only with one chlorine. Until your 10th standard, yes, if you are asked to write the molecular formula of sodium chloride, you write it as NaCl. But when you go to higher classes, NaCl X times. This will be the molecular formula of sodium chloride, because each sodium is associated with not one chlorine but all chlorines around it. Okay. Now, this kind of regular arrangement is called lattice arrangement, or this structure is called lattice structure. Anything which is having this regular arrangement will be reflecting the light that is falling in it back. So when the light is reflected back, that salt will shine, and that shining salt, we call it as a crystalline salt. Okay. And which does not shine, we say it is not crystalline. Now, NaCl, sodium chloride, is a crystalline salt. Okay. Now let us see, to my liking, the most beautiful salt is copper sulfate, CuSO4. Okay. And this copper sulfate does not come by itself. It is in combination with some water molecules. Okay. CuSO4, 2H2O. Now, when we heat this copper sulfate, which is in a very beautiful blue color, what happens is you see that the blue color slowly disappears and you will be left with amorphous white color salt. Now, what is happening here? You also see some droplets of water on the walls of the test tube, which you can see in the textbook. Now, that means this salt, copper sulfate, is actually having some water molecules in it. And when we are heating, these water molecules are coming out. Those water molecules are actually the droplets what you are seeing on the walls of the test tube. Fine. Now coming to the next part, this white color. This white color amorphous substance that is formed is again copper sulfate only without water. That means what happened? This water